Okay, can. Yeah, non-parallel sides are equal in length. Okay, so this will be a rhombus. Then question 18, I'm marking halfway. Part 1 is fine. Part 2, haven't seen yet. The x-axis is the line of symmetry of the triangle ABC. You have A is 7, 0, B is 0, -3. Correct. So if it's a line of symmetry, should be distance 3, top and bottom. So the coordinates of the C must be +6. So 0, 3. Right? This is fine. Then find the equation of the line AC. Yeah, just find the gradient, then sub in one of the points. Then you can solve for C. Or use point slope formula also okay. Let's see if the working is fine. Yes. Yes. Gradient equals y. Actually, yeah. You see, this is wrong, lah. Right? Because what is the y-intercept of AC? What's the y-intercept of AC?
3.
3, right? So this is definitely not correct, right? Yeah, don't need to use point slope formula. This one, sec 1 can do already. Don't need point slope, don't need point slope. Just y equals to the gradient x plus 3, okay? I think something went wrong here. What happened? You're substituting in 7, 0. The gradient is fine. Let me just double check. Yes, 52/7 is. Wait a minute. That's not right. Whoa. How do you get a 52? Let's work it out. -3/7 equals y over x minus 7. Cross multiply, make y the subject. So it's just -3/7 times x minus 7. Distribute -3/7 times x, -3/7 times -7. Negative become plus. 7 is 7/1. 7 cancels off. Then you get a 3. How do you get 52?
I don't know.
I have no idea. Okay, yeah, just do it step by step, then you won't go wrong. Okay, find the part 3. Yeah, that's part 3 already, Okay, I think there was another calculation error I saw. Was it before or after? The rest were fine. Okay, it's after. 19. Yes, here another careless mistake with the calculation. Do a bit too fast. Find the equation of the line through M perpendicular to the line. So you found the perpendicular gradient. Good. Then you sub in. This equation is fine. Then something went wrong with the multiplication here. You see, you should get -2/3 times 9. 3 and 9 cancels, then you get the correct answer. Here something is definitely wrong.
Yeah.
Okay, yeah, just multiply, cross multiply, and then distribute step by step. Then you won't make any careless mistakes. Okay, next. You can calculate this on your own. Let's see, question 20. You have 3 points, 1, 3, k plus 1, 2, -1, 4. Actually, do you check with the answer here? Is it correct?
Oh, I didn't check.
Okay, this is fine. I'm just gonna check the answer. If you get it right, then should be fine. Oh, we got a -6. Something is wrong, is it? Then there's a final answer. 1/2 is fine. Okay, I'll just check your part B. Given 3 points, P, Q, R, find the possible values of K in each of the following cases. Part B, QR equals to 2 times of PR. So how to find length of PR? You just take the square root of x minus x squared plus y minus y squared. PR 1 minus -1 is +2. Okay. Then 4 minus 3 is 1. Or 3 minus 4 is -1. Same thing. Bracket square will give you the same answer. So this will be 4 plus 1, which is a 5. Okay, then QR. QR is, this is Q, that is R. Just take the difference between K plus 1 and -1. That's K plus 2. Good. Then square it. And then take the difference between 4 and 2. That will be +2 or -2. Both are fine. Then you square it. Let's see. This will become K squared plus 2 times K times 2, which is 4K, plus 2 squared, which is 4. plus another 2 square, which is 4. 4 plus 4 is 8. Okay, this is okay. Then we know that what is equal to what? QR equals to 2PR. So QR equals to 2PR. You times 2 to the PR, you get 2 root 5. Is that square root 20? Yes, because this is square root 4 times square root 5, which is square root 20. Then they will be equal, square root 20 and this guy. Okay, good. Then you just need to solve. Bring the 20 over, you get minus 12. That is okay. Okay, your equation is fine. This is okay. Let me double check. Maybe you type wrongly. 1, 4, negative 12, 2 and negative 6. Oh, yeah, it's a negative 6. Let me double check. Oh, is it the answer key is wrong? Did I see wrongly? Two times k times 2 is 4k plus 2k is 4. 4 plus 4 is 8. Then this one PR is what? PR is... Okay, I think the answer key is wrong. Your working is fine. Huh, the answer key is wrong. Should be negative 6. We got the same answer. Okay, can.
Okay.
Then I don't check your part. C 21, because your final answer is fine. 5x minus 9. Okay, 19. 4, 1, 2, 3, and 12. Okay, good. How about 22? Is there no solution given? Okay, and let's see. So you got a points A, which is negative 3, 1, B, 1, 5, C, H, K, lying on a straight line. If C also lies on the line y equals 3x minus 1, find the values of H and K. I need to draw a diagram. If not, I cannot understand what they're saying. So let's see. You got this C, it lies on y equals 3x minus 1. Okay, then I'll just draw a positive gradient and it cuts at a negative 1. And C lies on it. You have negative 3, 1. So maybe somewhere here. This is point A. You have a B, which is 1, 5. So maybe this point here will be what? It will be y equal to 0, so 1/3. Then 1, 5 will be somewhere here. Let me just double check. If x is equals to 1, y equals to 3 times 1 minus 1, which is 3 minus 1, which is 2. So this will pass through 1, 2. That means my 1, 5 must be above the line. And 1, 5 being the coordinates of B. Then what am I trying to find? Find the values of H and K. A, B, and C also lie on the same straight line. Okay. If they lie on right. So they both. So this point C is the common point of intersection between the line AB and the line 3x minus 1, right? Okay, then we can just draw that. So AB will be something like this. Y equals 3x minus 1, extend a bit more. So that is probably your point C, if I didn't draw wrongly. Then let's see what you did. You found the gradient of AB. So 5 minus 1 over 1 minus negative 3, which is 1 plus 3. You get 4 over 4. That's okay. Then you have gradient 1 equals to sub in a point. Use the point slope formula. So y minus 5 over x minus 1. Sub in the coordinates of B and the gradient of AB. Okay. Cross multiply, you get y minus 5 equal to x minus 1. Then bring the 5 over. Minus 1 plus 1 gives you plus 4. Okay. Good. Then that's equation 1. What's equation 2? It's the 3x minus 1. So you solve them and you find the point of intersection. So x plus 4 equals 3x minus 1. Bring the x over. Are you sure it's 4x?
2x.
Yeah. 3x minus 1x is 2x. So here it should be 5 over 2. Then arrow carry forward. How to find y, just sub in into either 1 or 2. So I think 1 is easier. So 5 over 2 plus 4. That's 2.5 plus 4, 6.5. All right, then yeah, so error carried forward. You just need to have 5/2 here and 13/2 there. Okay. Yeah, that's the value of h and k. This guy is h, that guy is k. Okay, next one. Question 23. Question 23 is, did they provide the answer? They didn't. Okay, let me check your working. Straight line with equation x/a plus y/b equals 2 passes through the points a 3, 0 and b 0, 4. Find the values of a and b. So gradient of this ab you found out to be -4/3. Is that right? Yes. Okay. I think it's better if you just draw like 3, 0 is somewhere here. Then the b is 0, 4, so somewhere there. So it's downward sloping. Very clear. That's why that you have a negative answer. Okay, makes sense. Then you want to find the equation of the line. That's a smart move because you can compare it with the original form after you manipulate it. Let me just check your equation. Is it correct? M equals to, use the point sort formula, so gradient equals to y minus y1 over x minus x1. What is your point you're using? You're using 3, 0, so -0, then this one -3. That's fine. Times the x minus 3 over. So you get -4/3 times x minus 3. Distribute, you get -4/3 x. Negative times negative gives you positive. 4/3 times 3, 3 cancels, you're left with +4. That's fine. Good. Then now you start with the equation x/a plus y/b equals 2. You cross multiply by, sorry, you multiply left and right by ab. Right? So you're left with x times b times x plus y times a times y equals to 2ab. That's okay. Then you make ay the subject minus bx. Then you divide by a throughout. Okay, can. Then now you just compare. So what do you get? 2b equals to 4. So b equals to 4 divided by 2, which is 2. That's fine. Then negative b over a. Maybe I just highlight it. This guy is the same as this guy. That guy is the same as that guy. So negative b over a is now going to be -2 over a. Replace the b with 2. Then this is equals to -4/3. That's okay. Yes. Replace the b with 2. And just solve for a. So times -1 on both sides, 2 over a equals 4/3. So 4a equals to 2 times 3, 6. Yes. And then you get a equals 6/4, which is 3/2. Okay, good. Then that is the value of a, but you're not done. You need to find the value of b. Oh wait, sorry. You already found the value of b. You already found the value of a as well. That's part 1 done. Part 2, the equation of the line passing through point B that is perpendicular to AB. So this guy. So you need to find the perpendicular gradient, sub in the point 0, 4, then you can get the equation. Actually, you don't even need to sub in now because straight away you know B is the y-intercept, right? So that's your C already. Let me see what you did. Gradient, 3/4. How did you get 3/4? You just flip it around and times -1. Right? That's how you get the -3/4, positive 3/4, sorry. And then you just sub in y minus 4 over x minus 0 because it passes through 4, 0, is it? Hold on, 0, 4, I mean. Yeah. -0 here. Then you just cross multiply and you get this. A simpler way is to just realize that this is the y-intercept. And you already have the y-intercept over here. 0, 4. Okay? Can? Yeah. And I realized, did I not assign you homework that last week?
Oh, yeah.
Okay, sorry about that. I forgot about it. Please let me know if I forget. Okay. And I also didn't send you the updated file. I just sent you the 220812. The name is a bit too long, so I shortened it a bit. Yeah, you can go look at the annotation there.
Okay.
Hey, Ken. Good. So what should we do today? I think we should. I have homework 2 lah, huh? HW2. You can. Did you try that already? Haven't, right?
Oh, sorry.
If you scroll back up. like on Telegram, the homework 2. That will be your homework, the end year revision. Okay. Then today, I think I shall go through the, what do you call this?
Wait, which one?
Do you see the message I sent? HW2 will be your homework 2.
Oh, HW2.
Yes. That will be your homework for today, I guess.
Okay.
Yes, correct. HW2. Let's record that in case we forget. What should we go through today? Is it a good idea to go through that lesson 2 worksheet? Okay, I guess we can. That's the plan now. So let's just do that. So download the, have you downloaded the 1_2_lesson02?
1.
Supplementary. 11.8 megabyte.
Oh, yeah.
That one. Okay, we'll go through that worksheet. Okay, give me a second to download it as well. Okay, hold on a second. Okay, where is it? Yeah, so we'll just do more practice on coordinate geometry. Okay, and then sky. Yeah. Can we cover everything? Or should I just, I don't think so. Maybe I should just select specific topics. I guess I'll start from the bottom. Resume. Yeah, can you see?
Yeah.
Okay, hold on a second. Let me do something. Yeah, okay, it's a copy this guy. Wow, lesson 02. This is so long-winded. I'm going to shorten the name a bit. Okay, let's just start from the bottom. I think it's easier. The questions are really just the same thing. Just more practice because you will need it for calculus. I mean, differentiation, integration. Quite an important topic. Coordinate geometry must be like super easy to do. Okay, can practice until you are very comfortable with it. Now, question 26. Let's see. The points A, B, C have the coordinates blah blah blah. There's an unknown P here. The figure ABCD is a rhombus. So find the midpoint of AC. We don't need a diagram for this one. M will be what? Will just be take the point of A, the x coordinates of A and C, so 3 plus 6 divided by 2. Then the y coordinates of A and C, which is -2 and 2, divided by 2. So this will give me M bracket 6 plus 3 is 9, 9 over 2. Minus 2 plus 2 is 0, 0 over 2 is 0. 4.5 over 4.5 comma 0, same thing.
Are you showing something on your screen?
Oh, right. Sorry.
Oh, okay.
Sorry. I forgot to resume chat. Okay. Can see now? Do you get what's going on? So points A, B, and C, they have this x and y. Just find the midpoint. Average of the x coordinates, average of the y coordinates. Is it okay so far?
Yep.
Okay, part 2. Equation of the perpendicular bisector of AC. So AC, we found the midpoints. Maybe I should draw a sketch. I think it's easier. Later, we need to use vectors to solve. Okay, let's see. 3, -2 is somewhere here, maybe. I'll just call this point A. Point B, we don't know. It's something, 3. Then point somewhere here, not sure. Then point C is 6, 2. Okay, so it's somewhere here. Point B is something comma 3, so it should be slightly above the 2, something P, B. So I will assume that the rhombus will look something like this. Maybe. Not so sure. P is the x coordinate. Could be anywhere. Could be anywhere. We are not sure. So we'll just, maybe it could even be there. We'll update the diagram as we go, as we figure out more things. Then the point D, here, if it's ABC, then D will be here. Oh, if it's ABC, then the D will be here. So there are many possibilities for point B and D. That's why we don't draw the point D yet. Just make sure we get more information first. Now, equation of the perpendicular bisector of AC. We know AC is here. Midpoint we figure out is here. Right, 9/2, 0. Perpendicular bisector must be this guy. So let's just find the gradient of AC first. That will be 2 minus -2. Right, then 6 minus 3. This is just 4/3. Therefore, m perpendicular must be -3/4. Therefore, equation of the line must be y minus away y coordinate of m, which is 0, divided by x minus x coordinate, which is 9/2, equals to the gradient -3/4. Solving, you get -3/4 times x minus 9/2. Multiply in, you get -3/4 x. Minus become a plus 3/4 times 9/2. Then you just use a calculator. 3/4. Oops. Hey, what's going on? 3/4 times 9/2. And you get 27/8. Is that okay? Can, good. That's the line, line perpendicular bisector of AC. Okay, can. Moving on to part 3. The coordinates of D. How to find the coordinates of D. So here, how? Where do you think is your point B? If point B is all the way here, our what do you call this? Our rhombus could be something like this. Do you think that's possible? Maybe, How about if our point B is a bit more to the left?
Oh wait, the question 1B from part 2.
Yes, correct. Yes, but we need to figure out where is point B first so that we can figure out our point B. But actually, let me go back to the original question, original assumption. This point B over on the right side. Is it possible? Is it possible for my point B here to be on the right side? The answer is no. You know why?
Why?
Rhombus, perpendicular, diagonals. And also, more importantly, the point B must be along one of the diagonals, which is this diagonal, right? So if it's somewhere floating on the right side, it doesn't make sense. It should be either here or there, right? But since this is comma 3, can it be at the bottom?
No.
No way, because positive y coordinate, right? So it should be above. That means it can only be here, somewhere roughly. Can you see that?
Then D will be like here.
And D will be at the bottom, exactly. Yes. No, it must be along the blue line.
Right
here. Yeah, something like that. Okay. Then we can fill in the blanks. I mean, draw the rhombus to make it more obvious. That will be point D. Then how do you find point D?
Sub y equals 3.
Sub y equals to 3 to solve for point D first. Okay. So sub y equals to 3 into, maybe I'll call this equation 1. The blue color line. Maybe I'll just highlight it as well. So sub in and you get what? 3 equals to -3/4 x plus 27/8. I'm just gonna scroll and solve. Now 3 minus 27/8. You get a -3/8 equals -3/4 x. So x must be -3/8 divided by -3/4. Or I think it's just 1/2, right? Because 1/2 times -3/4 will give you -3/8. All right, Ken. So x equal to 1/2, and that means we have our x coordinate here. I'm just going to erase away the p and put down positive 1/2. Is that okay? Can? Then now I think the simplest way to find coordinates of d would be
Vector.
So down, across, down, across. Oh, sorry, across. What's those distances? Let's see. So here, -2 to 3, that's a distance 5. 1/2 to 3, that will be 2.5. So same thing over here, 2.5 and a 5. So you just go across by 2.5, that means 6 plus 2.5. You go down by 5, so it's 2 minus 5. Is that okay? Yeah, good. 8.5 then -3. Right? 8.5 comma -3. All right, good. Then that is how we get our answer for coordinates of D. Okay, I'll just write it here. Okay, then moving on. Part 4, area of the rhombus. Shoelace. Yes, you got it. Very fast already. Part 4, 1/2, don't forget, modulus, and then just copy the coordinates. I'll just write it down. 1/2, 3, 3, -2. Point D, 8.5, comma, -3. 6, comma 2. Am I done? No, you need to repeat the original coordinates. Maybe that was a bad choice. I repeat the fraction. Makes my life more difficult. Then down, multiply, and then subtract away, up. So what would this be? 1/2 multiplied by? Oh no, so many things to copy. This times this, plus this times this, plus this times this. The red arrows are. Oops. Please let me know if I copy wrong. 3 times -3 plus 8.5 times 2 plus 6 times 3. That's for the first half. Subtract away the second half. Now, wow, no space. 3 times 3 plus -2 times 8.5 plus -3 times 6 plus 2 times half. Close the bracket. Close the modulus. Is that okay? And now we have to key in the calculator. Oh, modulus, I forgot to copy down. I think it's a 25. Minus away. Wow. -25. Is it correct? Okay, good. Then as a result, we get 1/2 times modulus of +50. Since it's already positive, we can drop the modulus now. Just 1/2 times 50, which is 25. Okay? A unit square, sorry. Unit square. Yep. Good. 25. Now that's area, part V. Perpendicular distance from point D to BC. So we need to, let's say we extend this line a little bit. Then we want to find the perpendicular distance here. Can you see? Let's just call this point E. Then there's a perpendicular line here. You want to find the distance PD, essentially, right? Perpendicular distance PD. How?
Find equation of line of BC.
Okay.
Then find gradient of PD. Use -1 divided by gradient of BC.
Okay, that's a gradient of DP, correct?
Then okay, then I don't know. Wait.
You got gradient of DP. How do you proceed? Just
You
find
can
the
find
equation.
equation of PD use point slope. Use point
PD, yeah. Yes, using point D. So you got the equation of DP. Then what do you want to do next?
You want to find the length?
How? But you don't have the point P yet. If you have
Yeah.
point P, then you can do distance formula. But how do you find point P now? Right, our
How?
goal now changes to finding the coordinates of point P. How?
You can do equation BC equal equation of PD. Then because the point of intersection is P, then you get P. Then you have P and D. Then you just use distance of line formula.
Correct. Okay, let's just do it. Okay, let me just copy down the diagram so I don't need to keep scrolling. Okay, I'll just paste it over here. Yeah, so let's just do that. Exactly what you said. So let's just quickly find that what's MBC. This will be 2 minus 3 over 2 minus 3 over 6 minus 1 half. Did I get the order right? Let me double check first. Yeah, okay. Then -1 over 5.5. This is something -2 over 11. Okay, therefore M of PD will be what? Perpendicular, right? So -11 over 2. Oh, sorry, +11 over 2. Is that okay? So we got gradient of PD. Now we have the point of D as well. So we can find the equation of line PD. This will be y equals to mx plus c. So 11 over 2x plus c. Don't use points, so I'm just going to use the traditional method. Sub in x and y. So 11 over 2 times 8.5 plus c. Maybe I'll just say in sub d. Sub d, okay. Then therefore you can get what? Times off. Just multiply. -3. Oh, maybe I'll just solve for c first. -3 plus minus minus 11 over 2 times 8.5. Okay, then just key in the calculator. -3 minus 11 over 2 multiplied by 8.5. And you get a -199 over 4. Wow, the number seems a bit big. So therefore, we get what? 11 over 2x minus 199 over 4. Number very big. If only there was a simpler, less troublesome way. There is, but let's just do this method first. Then we can check, we will get the same answer. Okay, so this is line PD. Call this equation 1. Actually, did I use 1 already? Haven't used 1. Wait, I did. I used 1 already, so I don't recycle. I mean, still the same question, so better not have a clash in notation. I'll call this equation star. Okay, guaranteed to be different. That is line PD not done yet. Now we need to find line BC. Equation of line BC. Do we actually have it? Line BC. Let me just double check. I can't remember. Okay. Let me double check. Line BC equation. Nope, we don't have it. So no choice. I have to go and find it manually. So first, you find the gradient of BC. What is this?
I already have gradient.
Oh, right. It's already found just now. -2 over 11. Good, save time. Then therefore, y equals to -2 over 11x plus c. Then you just sub in a point. Let's say we sub in 6, 2. So we get 2 equals to -2 over 11 times 6 plus c. This implies c is equals to 2 plus 2 over 11 times 6. Use a calculator. 2 plus 2 over 11 times 6. 34 over 11. Therefore, we get y equals to -2 over 11x. Add on 34 over 11. That is equation of line BC. Let's just call this double star. What do you do now? Equate the two equations star with double star. That's the line. This is line PD and BC. You find the BC is the same as BP. Maybe I'll just rename this as BP. So it's more obvious that they have a point P as the common point of intersection. So you just equate them. Star equals to star. Maybe I'll just write that over here. Star equals to star. Double star. And you get 11 over 2x minus 199 over 4 equals to -2 over 11x plus 34 over 11. Now bring them all together. Let's do that. So copy and paste this. I will be left with 11 over 2x plus 2 over 11x minus 1994 bring over becomes a plus. 34 over 11 bring over to the right. Equals. Okay. Now just collect like terms here. Something x. Just add the two coefficients. So 11 over 2 plus 2 over 11. Wow, looks so funny. Like a pattern going on. 11 over 2, 2 over 11. If only there's a deeper pattern that we can find. You can go figure out yourself.
What?
How come here is 11 over 2 and there is a 2 over 11? Is there a pattern? Does it always hold true? Like something on top, something below, something below goes on top, and something on top goes below. Does that always apply to perpendicular lines? Don't know. You can go figure out yourself. Okay, so now you realize it's getting quite big, the numbers. So just have to be a bit more careful when you're multiplying. So this one times 22 over 125. You get 93 over 10, which is 9.3. That's x. We're not done. We need to find y. So therefore, sub x into either star or double star. So maybe I'll just write it over here. Which one you want? Star or double star?
Oh, don't really matter. They're both.
Doesn't matter. Exactly. Yes. Both will give you the same answer. Hopefully, if I never calculate wrongly. 11 over 2 times 9.3 minus 199 over 4 is 7 over 5. Okay, which is 1.4. Okay, so now that we have the point P's coordinates, which is 9.3, 1.4, we can find the distance of the perpendicular line. So it's really just PD. All right, so let's find length PD, square root of x minus x. So 9.3 minus something square plus 1.4 minus something square. I can't remember the coordinates of D. Let me check first. 8.5 comma negative 3. Okay, so minus away 8.5 here, minus away negative 3, which is plus 3. But doesn't matter, just key in the calculator. Square root bracket 9.3 minus 8.5. Okay, maybe we don't square root yet. 8.5 bracket square plus 1.4 minus 3 bracket square. And you get a square root of 20, which is square root 4 times 5, square root, then you get 2 root 5. Okay? Can? If only there was a faster way. If only there was a faster way.
There is.
Yes, there is. Okay, let me redraw the diagram again. You should get back the same answer, square root 20. Okay, so using this other method, what you need to know is a bit of geometry. The area of rhombus, I think I explained this before, is really just half times d1, d2. Okay, length of diagonal 1 times length of diagonal 2 times half. Is that okay? Diagonal. So that means it's really just half times of AC and BD. Right? Yes? Is that okay?
Wait, can say it?
The area of a rhombus is equal to half times the diagonal lengths. Length of the diagonals.
Yeah.
Right? AC and BD.
Yeah.
But there is also another formula. A rhombus is just a special kind of parallelogram. Do you remember the area of parallelogram formula?
Is the this times that wait. Isn't it this times the like perpendicular length?
Do you need to times half?
No.
No, correct. Yes. The reason for that is because you can always transfer this over. Can you see? Then you end up with a what shape?
Rectangle.
That's why it's base times height. Of course, it's the same as this one, base times perpendicular height. Okay, yes, your formula is correct. And rhombus is no different from a parallelogram. It's just a special kind of parallelogram. So same thing, we can also take base times height. But here, can you see that the height is really just the PD? This is perpendicular height. And the base is just BC. So that just means this area can also be equivalent to half times PD, perpendicular height, times the base BC. Right? So using these two formulas, we can solve for PD. If we know AC, BD, and BC, we can just solve for PD. Does it make sense?
Yeah.
Okay, good. So let me toss this aside. I think that would be a lot simpler. Okay, this is, of course, requires you to know these formulas. If you don't know the formula, then you can't do it. Anyways, so these are two equivalent expressions for area of rhombus. Just copy and paste them together, equate them. What happens when you have half and half on both sides? Times 2 on both sides, cancel off. What are we trying to solve for? We're trying to solve for PD, right? Perpendicular lines. So PD equals to AC times BD divided by BC. So we just need to find out AC, BD, and BC part by part. Then just sub in and we'll get our answer. How? Distance formula? Right? You don't need to find equation. So I guess it's a little bit faster. I don't know. How much faster is it? AC, so x minus x square plus y minus y. So 2 minus negative 2 minus 2 square. What do you get? You get 3 square 9, 2 square, 4 square 4, 4 square 16. This is really just square root 25, which is just a 5. That's AC. How about BD? BD is what? 8 minus 5, 8.5 minus half square plus minus 3 bracket square. Take a square root. 8.5 minus half, just 8 square, 64. Minus 3 is minus 6. 6 square, 36. Just nice, it's a 100, which gives you a 10. How come the numbers here are so nice? Because it was planned that way. Okay, so that is BD. But how about BC? Let's find BC now. BC will be same thing. Just 6 minus half bracket square plus 2 minus 3 or 3 minus 2. Doesn't matter the direction. Just make sure you got a minus. Then 5.5 square. What is it? 5.5 square plus 3 minus 2 is 1 square. Add together, you get 125 over 4 square root. We can simplify this as square root 125 over square root 4. Of course, square root 4 is just a 2. 125 is actually 25 times 5. So that means that you get square root 25 times square root 5. But what is square root 5? What is square root 25? What is square root 25?
5.
So 5 root 5 over 2. Very good. Then now we can sub in. So we have 5 times 10 over 5 root 5 over 2. Here, when you have divide fraction at a denominator, you can bring the 2 up. So you're left with 50 over 5 root 5. Actually, let's just not times the 10 in. 5 times 10, leave it alone. The divide by 2 here, bring up, and you're left with a times 2 at the top. What happens to your 5? Cancels away. What are you left with? 10 times 2 over square root 5. We can rationalize it. So times root 5 top and bottom. We are left with 20 root 5 over 5. What's that? 4 root 5. What's that? I don't know. Is it the same answer as what we got? I think it's a bit different. Wow. Oh no. Oh no, oh no, oh no. Did I miss out something? Oh no, did I do something wrongly? Let me see. Right. Just now I told you already got half or not for area of a parallelogram. Have or don't have?
Don't have.
Don't have the mistake over here. Sorry.
Wow.
Oh my goodness. Sorry. I told you the mistake and I still made it myself. Sorry. Yeah, so there shouldn't be a half there. So no choice. The half must remain. Wow. Let me see. Make PD the subject. So yeah, there's still a 2 here. Can? Yeah, so everywhere have a 2. Let me just write it in a different color. 2 times remains, 2 times, so 2 and 2 cancels away. Then let me just redo this part here. Luckily the 2 cancels away, so we're just left with 5 times 10 over 5 root 5. 5 cancels away, 10 over root 5. Rationalize. So now you see where certs is important. Why certs is taught before coordinate geometry. You need to know your certs square roots before you can learn how to get the exact answer here. So this is
Why
square
if I forget how to do search already?
Then you cannot get the exact answer. Sometimes the answer will ask you to leave your answer in the form of a times square root b. Then find the value of a, find the value of b. So you need to convert into 2 root 5 and give me a equal to 2, b equal to 5. If not, you won't get the mark, the last one mark. So yeah, just learn it. Okay, can ask square root 20, same answer, very good. Okay, confirm correct. Do 2 different ways to get the same answer. Cannot be a coincidence. Okay. Okay, now this is what is this question? 26, the last question. Let's just go back to the let's just go to the next second last question, I guess. Okay, wait a minute. Wow. Notability. Okay, those that I cannot cover, just you can do as homework. In addition to the homework too. Okay? Yeah, let's take a look. So let's take a look at this diagram. We have a kite OABC whose diagonals meet at point M. Coordinates of A, B, and C are blah blah blah, respectively, where A and C are constants. This time it has 2 unknowns, a little bit more challenging. Find the coordinates of M. So I think you can see M is the midpoint of O and B. What's O?
0, 0.
Yes, exactly. So that means that for coordinates of M, it's just the average, 0 plus 5 over 2, 0 plus 3 over 2. Answer will be 2.5, 1.5. Answer. That's part 1 done. Let's move on to part 2, equation of AC. So, how? Oh, don't worry. We don't have A, we don't have C yet. Then how to find the gradient?
Midpoint lies on it.
Yes, correct. This is a kite, right? This is a kite. So that means perpendicular diagonals are perpendicular. So it's just the perpendicular bisector of OB, and we know how to find that. Just need to find the gradient of AC. You know that is sorry. Need to find the gradient of the OB first, which is 3 over 5, right? Rise over run, 3 over 5. Then MAC will be negative 5 over 3, negative reciprocal. Not enough, we still need to find the gradient of, need to find the equation by using point slope. Yes, correct. Y minus 1.5, x minus 2.5 equals to the gradient negative 5 over 3. Just cross multiply, you get y minus 1.5 equals to negative 5 over 3 times x minus 2.5. Then the minus 1.5 bring over, become plus 1.5. Plus 1.5. Okay, then you just multiply out. So negative 5 over 3x, negative become negative times negative gives you positive 5 over 3 times 2.5. This will give you 25 over 6. Don't forget the plus 1.5 at the back. At the end of the day, you get 17 over 3. Is that okay? Okay, now that is the equation. They gave it in a different format. 3y plus 5x equals 17. Do you understand how they are the same? Yeah, just times 3 and bring the x term over. Okay, good. That is part 2 done. Let's move on to part 3. Find the value of A. How?
Sub x equals 7 into the equation.
Let's just call it 1. Therefore, y is equal to negative 5 over 3 multiplied by 7, add on a 17 over 3. Just type in the calculator what do you get. You get negative 6. Okay, therefore, that is the value of A. A equals to this negative 6. Moving on, part 4. Coordinates of C.
Sub x equals to C and y equals to C plus 3.
Into
equation 1.
Very good, the equation of the line. Okay, then that means we will get C plus 3 as the y, negative 5 thirds times the x, which is now replaced with a C, plus 17 over 3. Then just solve for C. Okay. Here, minus 5/3 times C, bring over, become plus. Plus 3, bring over, become minus 3. And don't forget the plus 17/3. 1 plus 5/3 is what? 8/3. C equals to minus 3 plus 17/3, you get 8/3. So C equals to 8/3. 1. Okay, exactly. 1 times 8/3 gives you 8/3. Okay, good. So C equals to 1. Right? Yeah. Yes, then you have to give me the coordinates. So it's C, point C is C plus C comma C plus 3. So it will be 1 comma 1 plus 3, 4. Is that okay? 1 plus 3 is 4. Give the coordinates, answer the question. So part 4 done. Let's move on to part 5, area of kite OABC. Let me just copy down the diagram so I don't need to keep moving up and down. Paste it here. What's the coordinates? This is 7 comma, what was A again? -6. So -6. So this is 7 comma -6. And what is the coordinates of C again? It's 1 comma 4, right? Yeah, then we can find the area using shoelace. So area equals to. So recommendation is always to
As the first one.
put 0, 0 as the first one. Yes, because it will make your life easier when you do the multiplication. So let's just go anti-clockwise. Then there'll be 7 minus 6, then 5 comma 3, then 1 comma 4, then finally go back 0, 0. Is that correct? I hope so. Yeah, then just multiply out half. Modulus of something minus something. Let's just multiply it. 0 times minus 6, 0. 7 times 3, plus 21. 5 times 4, plus 20. 1 times 0, plus 0. Minus away, 0 times 7, 0. Minus 6 times 5, minus 30. 3 times 1, plus 3. 4 times 0, plus 0. Is that okay? Yeah, then just type in the calculator. What is this? 41 minus plus, let me think a bit. Plus 30 minus 3 plus 27. Yeah. Of course, you don't need to show this intermediate working. Just give me the final answer. Which is what? 41 plus 27. Half times 68, 34. Okay. Unit square. Units square. Good. Part 4. Any questions? No.
No.
Part V done. Let's move on. Ratio of AC to MC. AC to MC.
Just use length of line.
Yeah, just use the length formula, right? Okay. AC is to MC. Let me just write this down first in case I forget. So find the length AC is PI. AC will be what? Just distance formula. 7 minus 1 bracket square plus minus 6 minus 4 square. Simplify, you get 36. You get minus 10 square minus 100. This, sorry, there's a plus 136 is with a square root. Then what about MC? MC is equal to what's M again? I can't remember.
Midpoint.
2.5 comma 1.5. Okay, then we just calculate lor. So x minus x, 2.5 minus 1 bracket square plus 1.5 minus 4 bracket square. Simplify this without calculating the square root. 2.5 minus 1 is 1.5 square plus 1.5 minus 4 bracket square. And we get 17 over 2 or 8.5. Okay, so now we want the ratio of AC is to MC. It's just AC divided by MC, which will give us square root 136 over square root 8.5. Let's see what would square root 8.5 be? Actually, maybe we just take the square root of the entire thing. So 136 over 8.5, right? Then 136 over 8.5, this one can key in the calculator. Coincidentally, it's a 16, which can be simplified into 4. What does it mean? 4 is really just 4 over
4 is 4 over
1. 1,
Mhm.
right? Therefore, the ratio is 4:1. Is that okay? 4:1. Okay? Good. Moving on. Okay, all these I think quite simple for you, right? Too simple already. Let's see. Let's just do it one by one. I want to do some circle questions. If not, you already know how to solve all this. No point doing it. Okay, let's just take it. 24. So what do we have? We have solutions. Okay, what do we want? 24 is asking the diagram above, which is not drawn to scale, shows an isosceles triangle ABC. Where A is -4, 6, B is -7, 3, C is 2, 6, and AB equals to BC. The coordinates of the point D is 14, 0, such that AD is parallel to BC. So these two lines are parallel. Yeah, then the point E lies on AC, and is such that the area of triangle ABE is 1/3 of the area of triangle ABC. So show that angle ABC is 90 degrees. 90 degrees. So I hope you remember Pythagoras theorem. Yeah, that's what you need to show. So basically, how to show it? You have to calculate AC square. Then you show that it's equals to show.
Wait, can you just use the find gradient AB and then find gradient BC, then times then equal -1?
Can also. You want to try that instead? Okay. Sorry, I didn't think of that.
But actually, I want to try it because I want to see how you do.
Okay, let's just do that.
Yeah.
Both ways will work. AC square is just distance. So in this case, square, I think you know the square root formula for a length already. But once you square it, what happens to your square root? Cancel off, right? So that means we don't need to write the square anymore, just x minus x. So it will be -4 -2 bracket square plus -6 -6 bracket square. Calculate this, what do we get? You get 6 square 36, 6 square 30, 12 square 144, which is 180. Okay, then how about AB square and BC square? We just take the sum of the other half of the Pythagoras theorem, then check that they are equal. So AB square will just be x minus x bracket square plus y minus y, so 3 minus -6 bracket square. Due to lack of space, I'm not gonna write down the plus BC square on the same line. I'm just going to separate them. Okay, calculate what's this AB square first. Later, then calculate BC square. So -7 minus -4 becomes -7 plus 4, which is -3. Square it, you get a 9. Add on to the other guy, 3 minus -6, which is 3 plus 6, which is 9. 9 square, 81. 81 plus 9 is 90. How about BC square? Do the same thing now. So, by the way, again, reminder, AB involves the square root formula. Here, because there's an additional square, so it's square the square root. So I need to square the square root, which means they will cancel each other off. That's why I didn't put down the square root. Is that clear?
Yeah.
Yeah. Then likewise for BC square. So -7 -2 bracket square plus 3 minus 6 bracket square. This is nothing but 9 square, 81. 3 minus 6 is -3. Square, it becomes +9. This is 90. So what you realize, AB square plus BC square is 90 plus 90, which is equals to 180. They are equal. Then therefore you conclude AB square plus BC square equals to, what is the other fellow, AC square. Then you can say by Pythagoras theorem, THEOREM. We conclude that angle what is it? Angle ABC equals to 90 degrees. Okay, can I just do a short rant on something called if and only if?
Okay.
So in math, we have statements that are called if and only if, equivalent statements. You've heard of phrases like this, right? If I am in Orchard, then I am in Singapore. That makes sense, right?
Mm-hmm.
Because Orchard is over here, then Singapore is outside, right? But if you
Okay.
phrase it the other way around, is that still equal? Is that still equivalent?
No.
No, right? Because if you are in Singapore, you may not be in Orchard. You may be in other locations as well. Makes sense, right? So
Mm-hmm.
there are certain statements such that the forward direction is okay, but the backwards direction is not okay. Not always true.
Mm-hmm.
So in math, we call this guy is sufficient to show that the other statement is true. Or you can say that this statement, I am in Singapore, is necessary for this original statement to be true. I am in Singapore is necessary as a necessary conclusion for I am in Orchard. I am in Orchard is sufficient to show that I am in Singapore. There's sufficient evidence to show that I am in Singapore. Does it make sense?
Yeah.
Kind of, right? Okay, so that is like sort of boundary between philosophy and math already. Certain statements can only go in the forward direction. This is the one that goes in forward. This other guy go backwards doesn't. In Pythagoras theorem, it's telling you that c squared equals to a squared plus b squared if and only if you have in this triangle, okay, we should have a triangle at the beginning, C, A, and B, 90 degrees here. Let's just call it point A, B, A, C, B, like this. Okay. Then the conclusion is that angle ACB is equals to 90 degrees. This is a if and only if statement, meaning it goes in both directions. Okay. Does it make sense? Mic test, can you hear me?
Yeah.
Okay. So yeah, certain statements they only go in one direction, but the other direction is wrong. But in Pythagoras theorem, it goes in both directions. If you have c squared equal to a squared plus b squared, you can conclude that the particular angle over there, opposite of the hypotenuse c, opposite of the little c, this is point C, the angle there must be 90 degrees. Likewise, if you have that angle is 90 degrees, you can conclude that c squared equal to a squared plus b squared. It goes in both directions. So when I say by Pythagoras theorem, I am quoting this theorem in particular, the theorem that goes in that direction. Does it make sense?
Yeah.
Okay, yeah, that's how I conclude it's 90 degrees. Of course, you can also do the m1 times m2 equals to -1. That also works. I'll leave that to you. Okay, part 2.
Okay.
Moving on. If you want to try, you can try the m1 times m2. Find the coordinates of E. How? Where's E? Point E lies on AC over here, such that the area of triangle ABE is 1/3 the area of triangle ABC. Mic test, can you still hear me?
Yeah.
Okay, 1/3. So in this case, what do you notice about these two triangles? They share the same
height.
Yeah, same height. So that means that the ratio of their area is really the same as the ratio of their
Length.
what length?
Base.
Base. So
AE
AE
to
over
AC
is 1
is
to 3.
1, 2, 3.
Correct. So that means maybe I should write this down. A of A1 over A2 will be equals to because they share the same same base. A1 is referring to area of the triangle ABC. And this one is maybe sorry, not ABC, should be ABE. Then the other guy is ABC. Then typically you know this formula, right? L1 over L2 bracket square. But here don't need to square, because they are not similar triangles. They are just common height triangles. So it's just the ratio of their bases, AE over AC. Is that okay? Then you realize that it's just 1:3 because the ratio of the area was given as 1/3. So now we know that it's 1/3. What do we conclude? I hope you can see that there is this two similar triangles over over here and here, right? And of course, what method are we going to use? What method are we using?
Vector.
Vectors method again. So what is the ratio? We know this length is 1 unit, this AC is 3 units, so this must be 2 units, right? Then you can draw the two, what do you call it? The horizontal and vertical lengths. Okay. So if this is ratio 1:2, that means the purple and purple will also be ratio 1:2. Green and green will also be 1:2. Is that okay?
Okay.
Okay, let me just get rid of those gray triangles to make it less messy. So let's figure out what is the ratio we should have now. From -4 to +2, what's the distance over here? -4 to +2.
6.
Exactly, no, +6. How about this total vertical distance here? From -6 to +6.
-6 to +6 is 12.
12. Now we have to split up into a ratio 1:2. So total is 1 unit plus 2 units, 3 units. 3 units plus 6. So 1 unit must be divided by 3, 2 units. So here must be a +2. Here must be a +4. Does it make sense? 1:2 ratio. What do you think is the green length now? Maybe I use pink color. 2, 4. What do you think is the green length?
18.
No. The total length is 12. Ratio would also be 1:2. So what's this length here? What's that length there? The short one should be?
Wait.
Confused already. Okay, wait, I write units first. 1 unit to 2 units. So you can call it 1x and 2x.
Okay.
1x plus 2x gives you 12. So what's x?
X is 4.
So here is 1x, which will be 4, exactly, right? Right. Okay, maybe I'll leave the x there. I'll leave the x there. Equals to 4. Then 2x will be equal to?
2x will be equal to 8.
Correct or not? 4 plus 8 equal 12.
Yeah.
Then this is 1:2 ratio. Right?
Yeah.
Similar triangles, so you should have 1:2, 1:2, and 1:2. Okay, purple with purple ratio 1:2. Green with green ratio 1:2. Is that okay so far? Okay, very good. So now we can figure out the coordinates of E already. Should I change this to pink color? Just to make it consistent. Ayo. No. I only want the. What's the coordinates of E now?
Coordinates of E.
I mean, it's here, but how do you work it out?
You take -6 plus 4.
Okay, then that's for the y coordinate. Yeah.
Then
Right,
for x coordinate, you take 2 minus 4.
2 minus 4. Can, yes. Or you can take -4 then +2. Also okay. It's the same thing, right? 2 minus 4 and negative 4 plus 2. The x coordinate of A plus 2 or the y coordinate of C minus 4. Same thing. And that's how you get the answer here. Minus 2, comma, minus 2. Okay?
Okay.
Vectors method. Very important. If not, you're going to spend a lot of time solving simultaneous equations. Very bad. Okay, now part 3. The point G is such that ABCG, where's ABCG? A is here, B is here, C is here. Where's G? Don't know. It's a square. So it must be somewhere here, right? G.
Mm-hmm.
Find the coordinates of G. So let's just draw in an extra line. Maybe it will land somewhere here. That's G. Question mark, comma, question mark.
Use vector.
Yes, use vectors again. So let me just hold on a second. Let me modify this a bit. I need to crop this. Oh, here we go. Yes, use the vectors method. So this is coordinates of G. I don't know the coordinates there, but I think you can tell here and here, right?
Mm-hmm.
Yeah, so we're gonna do that again. Purple, green, purple, green. So these two must be equal because opposite sides of a square are equal and parallel. So these two vectors are equivalent, which means the purple and purple vertical distance and the horizontal green distance are also the same. So let's figure out what's this purple distance here. Must be the y coordinate. No? So 3 go to minus 6. So what's the height here? Purple.
Purple is minus,
Length must be positive.
9.
9. Then how about the green?
3.
Yes, correct. Minus 7 go to minus 4 plus 3. So likewise over here will also be 9 and 3. So what's the coordinates of G now? This guy will be 2, the x coordinate of C, and you add on a bit more horizontal distance. A bit more. Plus how much?
Plus 3.
That's 3. Then the next one, start with y coordinate of
6 minus 9.
6 minus 9. Very good. Yes. There you go. That's your answer. 5, negative 3. Can? Okay, good. Okay, can. That's it. Okay, next. Go. 23. Yeah, you can do lah. You can do on your own. I'll leave that to you. Homework. Maybe you should write this down somewhere. In case I forget to send you. Oh, this is from the lesson 2 notes, question 23. Can Okay, moving on. Oh, this one. Can you do? I want to find an equation of a circle question. Gradient. Okay. Okay, I'll leave this as homework as well. Okay, can go and work it out. This one should be fine as well. Homework. Until question 23, 22, 21. Then question 20, I think we should try this. Yeah, should try this. Okay, let's try this question 20. So a straight line of gradient 1/3 is drawn through the point 7, 2 on the curve. Wow, what's this? 2y squared plus 3xy minus x squared equals to 1. Wow, what is this? Never see before, but never mind. Don't be scared. It's just some kind of equation. Doesn't really matter. You just need to know the straight line. Focus on the straight line. Gradient 1/3. So is it this way, or this way? Must be positive slope that way. Last option. Then it's drawn through the point 7, negative 2. So let's just label, positive 2. Okay, so let's just draw in some x and y axis. Now, I don't know where you will cut the y axis. So let's try and figure out the equation of the line first. Also, straight line equation, what would it be? Y equal mx plus c. But we know m is 1/3, so 1/3 x plus c. Then you can sub in the point. So 2, maybe I'll call this 1. I'll call this 2 in 2. And you end up with 2 equals to 1/3 times of 7 plus c. So solving for c, you get 2 minus 1/3 times 7, which is negative 1/3. Oh. Let's call this equation 3. Then calculate the coordinates of the point at which the line meets the curve again. Okay, let's read the question carefully. They say straight line of gradient 1/3 is drawn through the point 7, 2 on the curve. What does that mean? This 7, 2 lies on which graph? It actually passes through both the line and the curve. Did you catch that about English?
Not really.
So basically, there's some random curve. Don't care what it is. It passes through a 7, 2. Okay. Then what happens here is that let's see. Actually, the graph should be something like this. A bit negative 1/3 over here, right? Negative 1/3 below y-axis. So what happens is that the graph, the random curve, it just curves something like this, and then this line, it cuts through 7, 2. Okay, then this line continues to extend until it eventually intersects the line again at one particular point. The question is asking you to find the coordinates of that point. Let's just call it P. Is this clear? What the question is asking? Can Okay, my graph not very accurate. Let me just try and make it always increasing. Yeah, okay, good. That's not how the curve C, let's just call it C. 2y squared plus 3xy minus away x squared equals to 1. That's not how the equation actually looks like. You can go and Google for how the graph looks like, but that's not important. Our goal now is to find the coordinates of P. How do we do that?
Sub 2 into 1.
2 has an unknown C.
Oh, yeah.
Sub 2 into 1, but
I from the curve, then sub 7, x equals 7, y equals 2.
That will give you a 1. That will give you wait, what do you mean? 7, 2, we sub into 2 already, we solve for equation 3, right? Now if you sub in 7, 2 inside here, you should get a 1. Let's just double check. Just double check. You should get a 1, which is not useful. Okay, I demonstrate this to you. Because it passed through a point, of course it will give you of course it should give you a 1. Right?
Yeah.
So that's useless information. You don't do that. It's true, but not very useful. Don't do that. Instead, you have to find a point of intersection between these two graphs. What do you do when you want to find point of intersection? Simultaneous, right? So sub 3 into 1. Sub y with 1/3 x minus 1/3. Can?
Okay.
Yeah, that's what we're gonna do. So everywhere you see a y, just replace 2 times square plus 3 times x times minus away x squared equals to 1. So now you replace everywhere that you see with a y with 1/3 x minus 1. 1/3 x minus 1/3, sorry. Okay, then you proceed to solve for x. Of course, later on, you have to reject the x equal to 7. You want the other point. There will be a 7 in our solution. So let's just expand this. Okay, first thing, I want to factor our 1/3. So this becomes x minus 1. Then square, distribute So this, can you understand what's going on here?
Mhm.
1/3 square is 1/9, so it's really just 2/9 multiplied by x minus 1 square, which is x square minus 2x plus 1. Then you just add on 3x times 1/3 x. 3 times in, you'll get, leave the x outside first. 3 times in, you get what? X minus 1. X times in, what do you get? X square minus x. Okay, then minus x square equals 1 equals 1. Okay, now we try to simplify. Okay? X square minus x square. What a coincidence, they cancel each other off. I'm left with minus x equals to 1. This guy, 2/9, no choice, just copy and paste first. Or maybe I can just times in now. Okay, just times in 2/9 x squared minus with 4/9 x, add on 2/9. Then minus x equals to 1. Is this okay so far?
Yeah.
Okay, then now you have minus 4/9 minus 1. What do you get? You get minus 13/9 x. Everything else copy down. Copy down. Copy down. But you can go a bit faster. 1 also can bring over. So you're left with 0 on the right side, minus 1. Is this okay?
Yeah.
Okay, good. Then you simplify 2/9 minus 1. This really just gives you negative 7/9. Is that okay?
Mhm.
You can just key in the calculator already. 2/9, negative 13/9, negative 7/9. I get x equals to 7 or x equal negative half. Okay?
Reject.
Reject this one. So what you also realize from my diagram is that x equal negative half is okay. My diagram is not drawn to scale. Here is to the right of positive 7, but actually it should be cutting somewhere on negative half. So maybe the graph doesn't actually look like that. Maybe the graph looks something like this. I don't know. Doesn't really matter. Okay. It cuts here at a point P. Negative half, comma, question mark. Right? The x coordinate is negative half. We found out just now.
Mhm.
Then how to find the y? To find the full coordinates, you also need the y. How do you find the y
Sub into
coordinate?
equation 3.
Okay, good. You can also sub into equation 1, but that's gonna take more time. And sub into equation 1 and solve for y, but that will take a lot of time. Don't do that. Use the straight line equation. So 1/3 times negative half minus away 1/3. Type in the calculator. Yeah, just use a calculator. Whatever. Don't need to enter sums. It's okay. We have a calculator for this. I think I get a negative 1/2, right? Is this okay?
Yeah.
Okay, good. Can. Okay, can 20 done. Let's move on. Next one. Is this? Do you think you can do this?
Mhm.
And homework, homework. 19. Yeah, I have to circle the questions that is homework. If not, in case I forget to send you. Okay, can. I think we can try this question 18. That should be quite okay as well. Let's see question 18. So you have 3 of the vertices of a parallelogram are A, B, C, D, blah, 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 A, B, and D given, C not given. Find the coordinates of C and hence find the area of the parallelogram. So this is really just a vector question, right? Vector method. So just label the coordinates clearly and it will be quite simple to solve. 1, 2, 4, 1, maybe somewhere here. Negative 4, negative 2, so maybe somewhere a bit lower, maybe here. Then where is my, oh sorry, that's a D. So where is my point C?
Vector.
Where's point C? Must be somewhere here, right? Maybe, roughly.
Yeah.
Okay, good. Then let's just maybe I'll just label the point C somewhere here. Then vector method. So let's just find that correct vector to use. Do you want to try drawing? Sorry, try.
Okay, this is 1. Oh wait, this is 1. Then this is 3, 1, 3. So C is -4. Wait, sorry. C is -4 plus 3, comma, -2, -1.
Yep, correct. Good.
C is -1, -3.
Correct, exactly. And then from there, how to find the -1, -3. So from there, how do you find the area of parallelogram? You use the shoelace. Do I need to go through?
No.
Don't need. Okay, can. Shoelace. Yeah, you can do it on your own. Okay, let's try to find a circle question. I have to go through a circle question. Oh, this looks a bit difficult. Okay, let me try this question 17. Okay. Let's take a look. Given the coordinates of these points, find the equation of the line AB. Okay, let's just do that without a diagram first. So m of AB, gradient always. So you just take y minus y over x minus x. This will give you a -12/9 divided by 3. You get divided by 3, you get a -4/3. So that means the equation is what? Which one is the y-intercept? AB.
Y-intercept is 12.
Okay.
Wait, y-intercept is 9. Wait.
No.
Wait, y-intercept is 12. Y-intercept is 12. Final
Yes, it's 12. Okay. Yeah. So that means it's -4 third x plus 12. That's all. mx plus c. Okay. Part A done. Part B. Q is a point on AB such that the area of triangle ABQ is half the area of triangle OAB. Find the coordinates of Q. I have no idea what is BPQ and OAB until I draw the diagram. So let's take a look at the diagram. How would it look? Let me just draw my axes first. O 9,0, maybe here. 0,12. Wow, no space. Maybe just move my axis up. Where is my B? Maybe somewhere here. Okay, I need more space. Maybe somewhere here. This is what 0,12. What is that? 9,0. And then you have a 0,3 is a point P. Where is that? Maybe somewhere over here. Just extend a bit more. Okay, then you have point Q is a point on AB, such that the area of triangle BPQ. I need to draw the line first. BPQ is half the area of triangle OAB. Half. Since the BP is directly vertically down, I think there's only one possibility for the point Q. It has to be somewhere over here. Does it make sense? Half. Actually, is it true? I'm also not sure. But we can figure that out. Actually, let me think a little bit. Might not be so simple. AQ is a point on AB such that the area of triangle BPQ is half the area of triangle OAB. OAB. Well, there's a possibility that it's not horizontal. We can't assume that. What if it isn't? What if it's somewhere like this? That could be point Q, right? But in any case, to find, let's just pretend that's point Q. Then what will be the height of this triangle BPQ? What's a good base? What's a good perpendicular height? Can you draw for me? We focus on triangle BPQ.
BPQ. Oh, wait, what do you mean by good base and good height?
A good base, meaning it's easy to calculate the length of the base.
Okay.
There,
B.
yeah. That's just 12 minus 3, right? 9. Then how about height? Where would the height be now? Must be perpendicular. Over there. Okay, so let's use that, this guy and that guy as our base and height. So we know the green guy must be 12 minus 3, which is 9 already. That's the base. Then the height is this yellow guy. How do we find the height now? We need to consider, let's call this P prime. P prime. Question mark, comma, question mark. How do you find the coordinates? Can you tell me can you tell straight away what is the coordinates of P prime, at least for one of them? Comma 3, right? Because it's a horizontal line. Then if you know y coordinate is 3, how do you find x coordinate? P prime lies on
sub y equals 3 into equation of AB.
yes. Do we have line AB already? Yes, from part 1. Part A, I mean. So that means we can just get 3 equals to negative 4/3 x plus 12. Then if I bring the 12 over, 3 minus 12 is negative 9 equals negative 4/3 x. Multiply negative 1, you get 9 equals to 4/3 x. So that means that x is equal to 9 times 3 over 4. So that's just 27 over 4. Is it correct? Yeah. Okay, good. Let's just fill in the blank so it's not so messy. 27 over 4, comma 3. All right, good. Then how do you find the area of the triangle BPQ now? It's just half area of triangle BPQ.
Half times 9 times 27 over 4.
Yes, good. Okay, then in that case, what would that be? Let's double check first. 0.5 times 9 times 27 over 4 is 30.375. They tell you that this area of triangle BPQ is half of the area of triangle OBA, right? OAB. Is that true? Let me just double check. OB is what? 12. OA is what? 9. So half times 12 times 9. That's 54. That's not true. Oh no. That's 54. Is it half? It's not half. What does it mean? What does it mean about point Q? Okay, wait, compare. This is what we found. Area of triangle. Oh, sorry. Half times 9 times 27 over 4 is not OB. It's not B. Let me double check first. Sorry, I labeled wrongly. This is not BPQ. This is BPP prime. Did you realize that? Half times base times height is actually BPP prime. That's not the height of the triangle OPQ. Do you see? Let me zoom in.
Yeah.
The height should be yellow plus a bit more. So,
Yeah.
And it's obvious because the area of triangle BPQ is bigger than the area of triangle BPP prime. So now that we know that this triangle here is what do you call it? Is 30.375, and it's bigger than half ratio, right? We need the ratio of the actual BPQ to be half of OAB, which means that we should times half to this 54, which will give us a 27. So we need an area of BPQ to be 27, which is smaller than 30.375. So what does it tell you about the point Q? Where must it lie? Here is too big. Exactly at P prime, it's still too big. So where should Q lie? Can you draw on the diagram? Can you draw on the diagram where should the Q? Somewhere over there, right? Okay, good. All right, can. So that is the actual location of Q. So we remove the old diagram of Q. Your coordinate geometry trick here is you draw a diagram, just commit to it and pretend it is true. But then you eventually realize the numbers doesn't make sense. Then you edit your diagram, erase away, then you update the point. So now it should actually be here. So now we want to find what? Area of triangle, sorry, the coordinates of Q. You also realize that it is still a horizontal height here times a base, which is 9 here. So the area of, actually there was a simpler way to do this. We could have done this earlier. Area of triangle, what's this fella? BPQ, not BPP, is half of 54, which is 27 units square. And we know that this area is actually just half times AP times the y, times the perpendicular height. And this is exactly equal to the x coordinate of of Q. Do you agree?
Yeah.
Does it make sense? The x coordinate here will be the height. Maybe I highlight in light blue, like this. Perpendicular height here is x coordinate of Q. Can but what is AP? It's 9. So sorry, do you say something?
Yeah, I agree.
Okay, then you just replace this with your 9. So that means you get half times 9 times perpendicular height. Then just simplify this down. 27 equals to 4.5 times the height. So height is equal to 27 divided by
4.5.
You get 6. Good, 6. So that means that the coordinates of the x coordinate of Q we have found out already. So Q must be 6, question mark. But where does Q lie on?
Q lines on AB, sub x equals 6 into equation of AB.
Correct, yeah, good. Yes. And therefore you can get the corresponding y coordinate. Let's just quickly calculate that. So negative 4/3 multiplied by 6, add on a 12. 6 and 3 cancel, become a 2. 2 times 4 is 8, minus 8 plus 12 is 4. Is that okay? That's your answer. Okay, wait, I put down a question mark first. Then I update. This implies Q is 6,4. Done. Is that okay? A little bit challenging, but not too bad once you draw the picture. Okay, part C. Let's see. Find the equation of the perpendicular bisector of AB. Yeah, easy. Find midpoint, find the gradient, then -1 reciprocal. And you have a midpoint as well as the gradient, point slope formula. Right?
Yep.
Okay, let's just do that quickly. 1028. Okay, should I skip this? No, I need to do this because the part D and part E is interesting. Okay, let me just copy this down. Part C, find equation of the perpendicular bisector of AB. So midpoint of AB. This will be, take the average. So 0 plus 9 over 2, 12 plus 0 over 2. And you end up with midpoint of AB being 4.5, 6. So now that you have the midpoint, we are not done. We still need the gradient of AB, little m of AB, which will be 12 over 9 but negative, which is negative 3 over 3. Wait, no, 4 over 3. Therefore, gradient of the perpendicular must be positive 3 over 4. So you have this gradient, you have this point. Perpendicular bisector will pass through, will have a gradient of 3/4 and pass through this point. This implies the L perpendicular bisector must be equal to, not equal, dot, must be y minus away 6 over x minus 4.5 equals to the gradient 3/4. Is that okay? Point slope formula?
Yep.
Can? Good. Solving, you get y minus 6 equals 3/4 times x minus 3/4 times 4.5. Minus 6 can bring over, become plus 6. Simplify, you get 3/4 x. Multiply, the numbers just multiply. Negative 3/4 times 4.5, add on a 6. You get 21/8. Are we done? Yeah, that's it. Equation of perpendicular bisector form. Now move on. Part D. What is it? C is a point on the perpendicular bisector of AB and is equidistant from the positive x and y axis. Find the coordinates of C. What does this statement mean? Equidistant from the positive x and y axis.
What does that even mean?
Means equal distance from positive x and y axis. So let's see. If you have a point over here, this is the distance, perpendicular distance. That is the distance, perpendicular distance from the y, from the x. Is that equidistant? Equal distance? No lah. One long, one short. When does it become? And how about this one? Is this point equidistant? Of course not lah. One short, one long. So when is it exactly equal? When it lies along y equals to
X.
Exactly. In other words, any point here, P, if its x coordinate is A, sub in x equal to A, what do you get? Y equal to A as well. So A comma A. It will pass through A comma A. Is that okay?
Yeah.
We're gonna use that. Oh my goodness, what happened? Yeah. What? Don't know what happened. Okay, C is a point on perpendicular bisector of AB, equidistant from the positive x and y axis. Find the coordinates of C. Okay. So okay. So what this means is that it must lie along y equal to x. So for this y equal to x line, it must appear over here. And they tell you that you have this point. That's the point, which sits on line AB as well. So this is really just indirectly telling you simultaneous equation. Find the point of intersection between y equal to x and line AB. Is that okay?
Yeah.
Then that point will be equidistant from the x and y axis. Sorry, I forgot to label y, x. Yeah, so what part are we at already? Part D, is it? So equate. I'll call this 1. 1 and y equal to x. So we end up with x equals to 3/4 x plus 21/8. How? Solving. So 1x minus 3/4 x, left with 1/4 x on the left, equals 21/8. Solve for x times 4, 21/8, multiplied by 4. 4/8, half, 21/2. What's the corresponding y coordinate?
Sub into. Wait. It's just 21/2.
Yes. Equidistant. Now remember the A comma A? Yeah, so that's your point. 10.5 comma 10.5. Yeah, 10 half, 10 half. Good, that is point C. Part E. The point R lies on AB produced. Do you know what's AB produced?
Extended.
Extend, but which direction? Here or there? Top or bottom?
I don't know.
Must be top. That's the phrasing. Sorry, it's just English. A, B produced. Must go in the same direction as you read it. A then to B produced. So must be on top in the same direction like this. Is it clear?
Yep.
Okay, so point R lies somewhere here, such that AR equals to 5/3 of RB. Then calculate the coordinates of R. AR equals 5/3 RB. Let's just draw on this diagram. Extend, extend. I need to, let me just copy down this diagram. What did you say? AR equals to 5/3 of RB, right? So I'm just gonna label this length like this. This is AR. It's 5/3 of RB. Where's RB? Here is RB. 5/3 means what? If I rewrite it as a fraction, I will get AR over RB. What's the ratio?
5:3.
5:3. So that means I'll put down a 5 here, 3 here. Okay? Can? Now we filter out the relevant information. It's really just point A, point I, point B. Let me just copy the diagram again, but this time I erase all the irrelevant information. Gone, 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 gone. Yeah, bigger eraser. Okay, gone, gone, gone. All the irrelevant information. Okay, close enough. Yeah, like this. Can filter, must filter. Then in this case, we know the ratio is what again? 5:3. So that must mean that the remaining part here must be 5 minus 3, which is 2 units. Is that okay?
Yeah.
So maybe I can label here 2 units. Here is 3 units. Then of course, what method do we use? Ratio method. So let's find the length here and there, here and there. Of course, the ratio will still be 2:3. Maybe I draw a square shape to represent a different ratio. Square here, square here. Triangle here. Oh, triangle like this. Triangle here. So figure out the length for me, please. Let's find out this length. This is just 9, right?
12.
Oh, sorry, you were writing something. Yes, correct. Then after that, this will be 12. Good. So this length here, 2:3 ratio. So if this is 9, 12, very good. Yes.
18.
18, yes, correct. If this is 2 units, 1 unit will be 6. So 3 units will be 6 times 3, 18. Okay, so now what's the coordinates of R?
R would be 18. Wait, I mean 12 and then 30.
12, 30. Wrong.
No.
Because it's towards the left and then upwards. So here the x coordinate
minus 12.
Minus 12. Then 12 plus 18, 30. Yes, correct. Okay, must know the direction. Left then negative. Right then positive. Up is positive. Down is negative. Okay, you're starting from B, moving towards R. So you move left, then you move up. So the x coordinate must minus, y coordinate must plus. From B, from B. Okay, then why is that? I don't know. Minus 12 and 30, yeah. Okay, can. Good. Clear? Can, Yeah, so must learn how to filter out the relevant information. Then just start erasing all the irrelevant stuff. Just redraw. I think it's easier. Just 3, 2 is all you need. And the coordinates of B and A. Okay. Good. Yeah, then produce, I must also remember what it means. A, B, produce means you start at A, go to B, then you produce to a point R in the same direction. All right? Okay, can. Okay, time for one more question. If not, okay, I need to find a circle question. Let me find first. You can try 2. Okay, I'll just try 2 questions. See how much I can cover. I'll try 14 first. The rest that I did not Sorry, I didn't circle all the questions. Though the rest that I did not cover, please try them as homework in addition to the HW2 homework too. Okay. Can. So let's try question 14 first. Now you got a circle equation, x squared minus 4x plus y squared plus 7y equals 0. Find the coordinates of center and radius of circle. I think you know by now, complete the square, right?
Wait.
So
Yeah.
you see minus, you copy down minus. You see 4, you don't write 4. Divide by 2. Or simplify straight away, 2. Bracket square, then minus away, same number. 2 square. Sorry. Yeah, then plus, next one is y plus 7 over 2 bracket square, then minus away, 7 over 2. Good, equals 0. All right, then now just copy down, then bring over. So positive 2 square, positive 7 over 2 bracket square. Type in a calculator and you get, I don't know, I can't calculate so quickly, 65 over 4, okay? Which is the same as square root square. Square root 65, then 2 bracket square. So therefore, conclusion is something square plus something square equals to something square. Center must be 2 comma
2 comma negative 7 over 2.
Good. Radius.
Square root 65 divided by 2.
Make sure you have a square outside. Okay. Square root 65. Let me think. 65 is 5 times what? 13. Yeah, square root. You can't really simplify anything. 5 and 13 are prime numbers. Okay, so that's your answer. The exact value. Okay, not enough. Now we need to solve the next half of the question. What did they ask? Part B. Point -2 comma -3 lies on the circle. Find the equation of the tangent to the circle passing through this point. Haha, this one haven't learned differentiation. Can you solve this? Tangent.
Find the equation tangent to the circle. Find the equation. Okay.
Let me calculate square root 65 over 2 first. Square root 65 over 2 is approximately, this guy is approximately 4.0311. So that means my diagram here, if I pass through 2 comma negative 3.5, my radius 4. So it should be something along the lines of this circle. Does it make sense? Question, is the origin inside the circle on the circumference or outside the circle?
Inside.
How do you check? How do you check? How do I know for sure? What if I never draw correctly? Maybe it's a bit smaller, like this. Or is it exactly?
2
or is it
plus,
bigger?
you take 2 plus square root 65 over 2.
2 plus square root 65 over 2. That will give you the horizontal length, right? Not really. I'm asking origin. Is it outside the circle, on the circumference, or inside the circle? What's the strategy? You're supposed to find the distance between origin and center. Then you compare it with what? Compare with the
radius.
Okay, so let's just call this point P lah. Then in this case, vector, length OP will be what? 2 square plus 3.5 square root. That would be, I have no idea. I need a calculator for this. Okay, what a coincidence. This is just 65 over 4. Square root 65 over 4 is nothing but square root 65 over 2. So coincidentally, it is the length of the radius. So what does it mean about the point O?
Origin lies on
circumference, right? That's the accurate way to draw the picture. Do you get what's going on?
Okay.
Cannot be inside, cannot be outside. Yeah, so drawing a circle also needs some skills. I cannot just plot a point and draw a circle. No. You need to figure out where will the circle pass through. Will it be here, here, or here? You don't know. You need to try and guess and check. Because I have notability and a circle tool, I can know that this will pop above the point. But actually, without the tool, you should still be able to tell that it will pass through this point. This it will still pass through the points or the origin and go above and then go below again. Right, that's the only way you can draw a circle, right? Hopefully, yeah, this makes sense to you. Good. So now the question. Read the question. Find the equation of the tangent to the circle that's passing through this point. -2, -3 lies on the circle. Where is -2, -3? Since the radius is 4.03, that means that the point over here would be 2 minus away that square root 65/2, which is approximately what? I want the approximation, so it's easier to understand. It's around -2.0311, -3.5, correct? So if -2.03 is here, where is my -2? To the left or to the right? Of course, it's to the right.
To the right.
And then negative y coordinate is -3. So is it above or is it below?
Above.
Above. So that means the point must be over here. Can you see?
Okay.
So you need to use these 4 points as reference. I hope you remember the exercise I asked you. Just go and find those 4 coordinates. You need it as a reference point so that you know where to plot your -2, -3. So it's actually over here. Then the question is asking you, find the equation of the tangent to the circle passing through this.
Find gradient of O and I don't know, call this
What do you want to say?
Y.
Y. Okay, can.
MOY.
So you want to find the gradient of MOY. Wait.
Then
Hold
point slope.
What were we trying to find again? Let me see. Find equation of
Equation.
tangent. So we are trying to find tangent line. This is red line, which passes through this single point only. What we are supposed to do is to know a trick. You find OY a bit no point. That's a secant line actually. That's not a tangent. That's not the same. What you should do is to remember circle angle properties. What angle is this? Tangent perpendicular to radius. You need to know that. Okay, so perpendicular, therefore you can find the gradient of YP, -1 reciprocal, you get the gradient of this tangent. You have a point, you have a gradient. What do you do?
Point slope.
Point slope, exactly. Well done, yes. Now you are ready to study physics and Newton's circular motion. Okay, no. Maybe not yet. You need to learn differentiation first. Yeah, so let's just do that. So MP capital Y equals to, or what is it? Y minus Y over X minus X. This is, what is this? 0.5 over -4. This is 1 over -8. So that means that the M of the tangent, which is perpendicular to the radius, this is a radius PY. It will be +8. Because tangent perpendicular to radius. Is that okay?
Yep.
So now that you have the gradient of the red color line, the tangent, then you just need to use the point -2, -3. And you can find the equation of the tangent line. What is that line that we gave it? What's the name? I don't know lah. No name for it. I just call it a tangent. Okay. So L tangent, TANGENT, will be y minus away -3 over x minus away -2 equals to the gradient +8. So y plus 3 over x plus 2 equals to +8 times over, you get 8 times x plus 8 times 2, 16. Don't forget plus 3 bring over -3. Left with y equals to 8x plus 13. Finally done. Can I just teach you one more extra way
Yeah.
Now, this is a technique that you have yet to learn. It's called differentiation. So what differentiation does is there's a recipe you need to follow. Then it will help you to find the gradient of a tangent line passing through this point. So let me just copy this down. I'll just demonstrate it without explaining what's going on. Then few weeks later, maybe 1 month later, we need to cover trigonometry first. Then you will figure out what's going on. It takes a while. Okay.
Okay.
Okay, I'm just gonna do it. See how much you can catch. You only need this. You will only understand what's going on maybe a few weeks later, unless you already learned this. Okay, so let's take a look. So what we have is the equation of a circle. It can always be split into two halves, the top half and the bottom half, if you make y the subject. And that's what you need if you're trying to differentiate with respect to x. So here we're gonna bring that bring the x minus 2 bracket square over. Then we're going to take the square root on both sides. So this guy remove, you're left with a square root of this guy plus minus. Now, because we want the top half, we're going to ignore the negative root. So we're just going to simplify this down into just the positive root. Positive, don't need to write. Plus 7 over 2 can bring over. You're left with y equals to negative 7 over 2 plus the square root of that value. Now, we can simplify this down because it will make things easier to differentiate. Maybe I'll just simplify a bit more. This guy is 65 over 4 minus bracket x squared minus 4x plus 4. Close the bracket. Equals minus 7 over 2 plus square root of 65 over 4 minus x squared plus 4x minus 4. 65 over 4 minus 4, what's that? It's just 49 over 4. Okay, then after that, this is the equation of the top half of the circle. Let me highlight it. Top half, the gray one, is this fellow over here. Then what we're going to do now is something called differentiation, dy by dx. I'm just going to do it without explanation. Constant term here, okay, maybe I do it directly below. Constant term here, differentiate, what do you get? You will get a 0. Plus, you need to memorize this. Plus, what happens? Square root here, if you recall, it is actually just the power half. So that means that you can actually reinterpret this as power half, bring down the half power. Bracket, bracket, then you have to subtract 1. Bring down the old power minus 1 to get the new power. This doesn't make sense to you, it will eventually make sense to you. Half minus 1. Then after that, you will have to copy down the expression inside. But because this expression inside is not a single x, it is something more complicated, we need to do something called the chain rule. Chain rule, it requires us to continue the expression by multiplying by the derivative of the inside. So derivative of the inside, what do you do? Term by term differentiation. 49 over 4 is a constant. Differentiate, what do you get? You get a 0. Because the gradient of y equals 49 over 4 horizontal line is just 0. Then how about minus x squared? Must remember the power rule. So bring down the old power times x minus 1 to get the new 2 minus 1. Alien language, I'm sure if you haven't learned differentiation, plus 4x. What's the gradient of y equal 4x? It's just 4, so put down a 4. Okay, then our differentiation is done. We need to clean up. Okay, clean up. So what do we get? Half multiplied by half minus 1 is negative half, so we get 1 over something power positive half. What's the something? Copy and paste. So you realize that in differentiation, you need to be very familiar with your indices already, your exponents. Then here you go and simplify 4 minus 2x. Okay, good. Now we need to, maybe I'll just clean up a bit more. 4 minus 2x, I'll bring it up to the numerator. So times 1, then I get 4 minus 2x like that. Actually, times half, I can also factor out a 2. So this becomes 2 times 2 minus x, which means that I can cancel off with the 2 at the bottom. So I'm left with 2 minus x divided by something power half. Now, let's take a look. What do we want? We want to solve for the gradient of this tangent line at the point x equals to negative 2. I'll highlight negative 2 here. I'll highlight the tangent. Then let me just copy the diagram down a bit. We now want to find the gradient of that line. Now magic formula tells you 3-step procedure. Step 1, differentiate. Step 2, equate to 0. Step 3, solve. Step 4, okay, maybe one more step. Sub x back into dy by dx, whatever that means. Let's just follow the procedure. We have finished step 1, differentiation, some long-winded procedure. Step 2, equate to 0. So what this means is we're going to set dy by dx equals to 0. What do we get? We will get 2 minus x over square root of whatever, square root because power half equals to 0. Okay, but what is square root? It's always a positive value. So if this is positive, how do you get 0? Can you answer this question?
Please say again.
When power half is always a square root means that the value will always be positive. Okay, it could be 0. Let's just pretend it's not 0. If not, it doesn't make sense. Divide by 0, not allowed. So this bottom is always positive. You have a fraction. What do you think should be the numerator in order to be equal to 0?
0.
Exactly. 0 divided by anything gives you 0. So solving, you get x equals to 2. Huh? So when x is equal to 2, it will give you the was it? Sorry. Oh no. That's the sorry. This is the procedure for finding stationary points. Here we're not trying to find stationary points. We're trying to find the gradient of the tangent line, the purple color line, which we already know the x coordinate to be -2. So there's no need to set equal to 0. Let me just remove this. I know it doesn't make sense. What's a stationary point? Just try and figure out whatever you can for now. It probably doesn't make sense. You can watch back the lecture recording and the recording of this lesson eventually once you learn it. So what we want to do now is to find the gradient, right? So we can just sub x equals -2 into dy by dx. Maybe I write that down, into dy by dx. This magic dy by dx formula will give us the gradient of tangent lines at a particular x coordinate. So that's what we're going to do. We're going to copy down the expression for dy by dx. Then we're going to sub in the x with -2. So everywhere there was an x, we replace it with a -2. Now this will give us the gradient of the tangent line at x equals to -2, and of course y equal -3. -2, -3. But you only need to focus on the x coordinate. So if you just type this inside the calculator or do it manually, you get 4 over, I don't know, some big number. Let's see, 49 over 4 minus away bracket -2 bracket square plus 4 times -2. You get 1/4 power half, which is what? What is square root, right? Square root of 1/4 is what? Half.
1 over 16.
Huh? No. Square root, power half, not 2.
Yeah, I mean 1 over 2.
Square root 1 over square root 4, which is 1 over 2. Yeah. So 4 over half is actually
1 over half is just 2.
sorry, 4 divided by half is, oh my goodness,
4 divided by half is 8.
8. Gradient of the tangent found, 8. Look. It is exactly the same as the gradient that we found using this method. Dark magic. Wow. It's the same. Did you notice that? This very weird procedure managed to produce the same answer. Who came up with this method? The guy who, the F equal ma guy, Newton. Okay. Do you get what's going on?
Obviously not.
Definitely not. Okay, you will eventually at the if I finish the syllabus, you should be able to know this and even more. Okay, it will take more time. It will take more time.
Okay.
You need to be able to learn this. You need to be able to understand this very easily. Okay, can. So now that we got the gradient, then can proceed to find the equation of the line. Gradient plus point. Okay. For now, that second method where involving the differentiation, you don't understand, can ignore it, but you must know the tangent perpendicular to radius. Okay, then that's all the time I have now. You can try the rest, question 13. Okay, plus
Okay.
homework 2. Okay, that's all for today.
Okay, so my homework is this one and the homework 2.
Correct, yes.
Okay.
Okay.
Cool.
Can. See you.
Okay.
Bye-bye.
Thanks.
Thank you.
Bye.